Let's take a look at working with even and odd functions on a TI-84 plus calculator. General idea is if you got an even function, this is an example of one, it's symmetric to the y-axis, which means you can take the right side of the graph and you can flip it across this the y-axis and it'll land exactly on this side of the graph. That means it's symmetric to the y-axis, and which means it's even. So again, let me just sketch that. Symmetric. It's probably not appropriate abbreviation, but we'll go with it. Symmetric to the y-axis. Now odd. This is going to be an example of an odd function. It's not so easy to see. It's symmetric to the origin. So that's symmetric to the origin. Now graph-wise, you start with one of your quadrants. Doesn't matter which one you start with. Let me start with the first quadrant here. If I flip it across the y-axis, it'll look like this right here. Now if I flip it across the x-axis, the question is, does it land exactly on this piece right here? And if it does, that means it's odd. So this is the graphical way to determine if something's even or odd. So let's look at a couple examples and see how to use that on the calculator. Okay, we want to determine if this function is even, odd, or neither. We got x to the fifth minus x to the third. Well, let's graph it. So I'm going to go to y equals, clear, if you have anything there. Then I'll do my x key, caret 5, minus, and then x caret 3. And press graph. Okay. Now, notice if I start with the first quadrant here, if I flip it across the y-axis, it looks something like this. And if I flip it across the x-axis, it'll land exactly on this piece. That means it's odd. Now, this will work for any quadrant. If I start with this little piece right here, it's going down here. If I flip that across the y-axis and flip it across the x-axis, it'll land on this little piece here. But this particular function here is odd. Let's take a look at this one. Press y equals, clear, and I got 3x squared plus 1, and then I'll press graph. Now notice, if I take my right side of my graph, if I flip it across the y-axis, reflect it across the y-axis, it'll land exactly on the left side of the graph. That means it's even, so this particular one would be even. Now I like to focus on this in my class because you know, the method of plugging in negative x for x, negative y and for y, and so forth. That's really nice. Gives them some practice in algebra, but this gives them a graphical view, and this is something that will benefit some of the students, not all of them. When I taught the animation courses in modeling, we would have something like this right here. And you would sit here and design something in this quadrant. You know, whatever. Well, I shouldn't have done something that hard. Okay, let me do something easy. If I drew this shape right here. Well, if you got something that's going to be symmetrical all the way around, then you can use tools that will then create this side. And it'll create this side, and even create this side. Just by drawing this one piece up here, by modeling this one piece, then you can have, by symmetry, you can have the other pieces already drawn. It saves you a lot of work in modeling and animation. So it really gets people thinking in terms of that about your symmetries. You know, what can you accomplish by working with just one quadrant? That's why I put so much focus on the graphical side of it versus the algebraic side. And that's working with the even odd functions on a TI-84 plus calculator.